Hello again everyone, welcome back to ptet.chemistry channel. So this is the last of the series of lecture tutorials for these 5129 combined science curriculum. I'm just only covering and also teaching only the chemistry curriculum. So my set of combined science tutorials are basically combined science chemistry tutorials. Even though I've said this for the 5129, this is equivalent to any combined science curriculum which involve elementary or very basic chemistry for the 14 to 16 years old students all around the world. So in this particular question, in this particular example, we have this hydrogen peroxide. We don't need to know what it is, but it is basically what people use to bleach their hair. When their hair goes like platinum blonde and stuff, they basically use hydrogen peroxide to do that. So hydrogen peroxide slowly decomposes, giving off oxygen gas. As you know, oxygen gas exists as this diatomic molecule. Diatomic means two atoms bonded together to give you a molecule. Oxygen being a group 6 element, they would just form two covalent bonds because they share two of their 6 outer shell electrons with another 2 electrons from the other oxygen, so that you get double bond, or this is called a double covalent bond there. Okay. When you use a catalyst, so we have come across this term called catalyst. We know that a catalyst speed up the rate of reaction. So that is why the oxygen gas is given off more quickly. So you get more oxygen in the same time. I don't say you get more oxygen altogether. I just say that you get more oxygen quickly, but then the total volume of the oxygen is still the same. That is because a catalyst is not a reactant. So a catalyst is not a reactant. If it is not a reactant, it doesn't undergo a reaction. That means it doesn't undergo a reaction that give you your product. It simply speed up the rate of reaction. It makes your reaction faster. In this case, your reaction is decomposition of hydrogen peroxide, giving you oxygen gas. So you just get the oxygen gas a bit faster. That's why the rate of reaction is faster when you use a catalyst. What is your objective here? Plan an experiment to find out which one of the 3 solid oxides. So these are compounds. The first one is manganese dioxide, copper oxide, as well as zinc oxide. You might not have come across them, but you will see where they are in the periodic table. So manganese dioxide is actually MnO2. This is manganese dioxide. If you look at your periodic table, let me just quickly open up my periodic table. So you look at the atomic number. Manganese is element number 25. Manganese Mn here is element number 25, atomic number 25. And there's manganese dioxide, so it's got 2 oxygen for 1 manganese. Copper oxide, Cu2 plus O2 minus. As you know, this should have been copper 2 oxide actually. So copper is element number 29 in the periodic table. And you have zinc oxide, so Zn2 plus O2 minus, so ZnO, which is zinc oxide. Zinc is element number 30 in the periodic table. Your job is to investigate which one is the best catalyst. So which one will give you the fastest rate of reaction. The best catalyst means you will get the fastest rate of reaction. That means the oxygen gas is given off very, very, very rapidly. You may use any common laboratory apparatus, and since we are giving off gas here, and we talk about in the last series of lecture tutorials, we talk about collection of gas such as this carbon dioxide from the last lecture tutorials, when you had calcium carbonate and marble chip reacting with HCl giving you a gas. You can collect the volume of a gas using something like gas syringe there, assuming, or provided you don't allow any of the gas to escape at all. You could also be looking at change in mass. Where was change in mass? Change in mass, loss in mass, as the mass is being lost as a gas here. So you're measuring the mass of the content. As you lose the CO2, the mass is going to decrease, its loss in mass. I think this particular example was about the gas collection, if I'm not mistaken. So yeah, actually you are allowed to use either method because your job is simply to find out which one will give you the fastest rate of reaction. The first thing that comes to mind is collect the gas. The second method, using gas collection, using gas syringe. But the other method you could use is in your conical flask containing the hydrogen peroxide, the catalyst. You can just weigh the content with the catalyst, which of course you need to use the same mass of the catalyst. Otherwise, the starting mass is not going to be the same for all of them. Those are just common logical sense. Include in your answer the apparatus needed. If I use gas collection, so if I use a gas collection, I need a gas syringe. So a gas syringe will collect the gas, and you need a brief description of the method. The shorter you write, the better, but make sure that it describes every single thing that you want to say about the method, such as gas collection and any safety precautions you take and why these are needed. Why are these needed? So you gotta talk about what are the danger of it. That's why you need to take certain precaution. So these are the hazards. Hazards meaning dangers, and safety precaution means well, basically how to protect against the danger, how to protect yourself against the safety hazard. So for instance, if you use something corrosive like acid, then you will use chemical resistant glove, but then we are not using acid here. We are simply producing a large amount of oxygen gas. Of course, you know oxygen gas support combustion. Oxygen gas is actually very dangerous in the sense that a little bit of spark would causes oxygen gas to ignite, and therefore you need to be very careful when you're handling oxygen gas to prevent it against any spark, any metal kind of sparking, and therefore igniting and therefore causing an explosion. The measurements you will make, what you will record or what you will make, this is going to be your y-axis. This is going to be your dependent variable. We talked about dependent variable in the last couple of lecture tutorial. I said, why are you so dependent? Why are you so dependent? Why are you so dependent? Y-axis, why are you so dependent? So the y-axis is what you record. That is your dependent variable. Control variable. So we talk about control variable. They can affect your measurement. They can affect your rate of reaction in this case. They can affect the time. Well, in this case, you are measuring the volume of gas, I guess, at a given time. So they can affect your rate of reaction. So you need to keep constant. So control variable are something that will affect the result of your experiment. Therefore, you have to keep them constant because we are not investigating them. We are investigating which one is the best catalyst. Therefore, we don't change temperature, we don't change concentration, because we are given hydrogen peroxide in water. So hydrogen peroxide is a solution here. So it comes with something that has concentration. It comes as something dissolved in water. We don't change the surface area of the catalyst. So that means if we use powder catalyst for one form, you gotta use powdered for all of them so that they have similar kind of surface area. But basically, we could also be thinking about the mass of the catalyst. We don't change the mass of the catalyst because if you are measuring the rate by monitoring the mass loss, you want to start with the same mass of this thing here. So there are a couple of things you can control. How you will process your result, how to process the result are very important. How you're gonna use that in order to draw a conclusion, basically the graphical method, as what the previous example, previous question had shown you. You need to plot the volume of the gas against the time. The steeper the gradient, so this gradient are getting steeper. Gradient are basically the change in y over change in x. As it become more and more vertical, the gradient, which is the change in y over change in x, lower secondary mathematics, that means the gradient increases. Going this way, the gradient increases because it's getting steeper and steeper, the rate increases. Whereas if you go this way, if you go the other way, so they are getting less steep, the gradient decreases, the rate decreases. Okay, so let's get started with this question actually. So you want to collect the volume of gas, right? So I will have a conical flask, and then I'll have a side arm, and then this side arm is connected to a gas syringe. A gas syringe has a piston, so this piston will get pushed out as the gas are being produced. And I gotta show graduations. Graduations mean it's got these lines that will allow you to record the volume of a gas. So this is called a gas syringe. It records or it measures the volume of a gas. This thing is a rubber bunk. You use a rubber bunk to prevent any gas that you have from escaping. And I'll have a little bit of this black solid. So these are the catalysts. These are the catalysts finely powdered. I want to use finely powdered catalyst so that they have the maximum surface area in order to bring about the catalysis, which is how fast they can speed up the rate of reaction. This is going to be my hydrogen peroxide, the stuff that will decompose to give you oxygen according to the question, because I know how to read the question. It decomposes, giving you of oxygen gas. In the presence of catalyst, it's going to be very fast. It's going to push out the piston as you collect the oxygen gas in here. So apparatus needed, label diagram, that one is done. A brief description of the method. So use a conical flask. So as short as possible, really. Use a conical flask connected to a side arm, connected sideway to a gas syringe. So you want it to connect to a gas syringe, then add in the catalyst for experiment 1. Add in the catalyst. Separately, you have 3 different catalysts that you wanted to investigate if you read back the questions: manganese dioxide, copper oxide, and zinc oxide. So you will add in the catalyst separately in 3 different experiments, because you have 3 different catalysts, 3 different experiments. And then quickly replace or quickly put on the rubber bunk. You want the rubber bunk to prevent the escape of gas. This is the rubber bunk there. You want to prevent the gas from escaping. You want the gas to fill sideways onto the gas syringe there. Record the volume of gas produced. The volume of gas produced after a fixed amount of time, after a fixed time. Recorded on a stopwatch. So you use a stopwatch monitor time. So for instance, you can say, example, after 20 seconds, after 30 seconds, or maybe after 1 minute, for instance, what is the volume of the gas produced by the amount of the catalyst that you added. Okay. Of course, that what are you going to measure? The measurements you will make, we're going to use a stopwatch to measure. So I'm running out of space here. I'll run the next page. So the measurements will be time taken for are we measuring time taken? No, we are measuring volume. Volume of gas produced after a fixed time. But you could also imagine this experiment where you can say or, not both, not and, but or, time taken for a fixed volume. Time taken for a fixed volume of gas to be produced. So either method will work. Either method will be able to tell you which catalyst is the best one to be formed or to be produced. But I think we'll be simply looking at number 1 instead of number 2. But you could see, experimentally speaking, as a science student, you should see both method will work. What you will control, as I mentioned, these are our control variable. So control variable meaning to say things you don't want to change, but they could affect the measurement of the time taken or the volume produced after a certain period of time. So these are control variables. I just need to write it in full. Temperature there. And then the concentration of the hydrogen peroxide, the surface area of the catalyst, which of course I had used finely powdered. So I used the powdered form. They have the maximum surface area of the catalyst to be exposed to the hydrogen peroxide, and therefore they bring about faster rate of reaction, as stated in the previous lecture tutorial there. The mass of the catalyst used, each of these catalysts are solid, ionic solid, consisting of metal cations, positive ions, and O2 minus oxides and ion there. Next one, how you will process your result. What do we know? What do we know about rate of reaction? So processing result, we know that we need to plot. So we need to plot what are we collecting? The volume of gas collected after a fixed time. If we are just looking at number 1 instead of looking at number 2, so we need to plot volume of gas produced, volume of oxygen produced after a fixed time. against the catalyst, against the 3 different catalysts. So 3 different catalysts, that is what we are changing the catalyst. Therefore, there's our x-axis, there's our independent variable. If I show you, we would simply have things like this. So this is time taken. Time taken for a fixed volume of gas to form or to be produced. So we would have, I don't know, I'm just showing you an example, something like this. I'm showing a bar chart here. So it could be catalyst, whatever, catalyst, whatever, catalyst, whatever. So as you could see, the time taken increases. So if the time taken for a fixed volume of gas to form increases, so what do you say about the rate of reaction? It takes longer time for a fixed volume of gas to be produced. So time taken increases. So that means the reaction is going to be slower. If the reaction is slower, it means it's a worse catalyst. So which one is going to be the best catalyst? That's basically what they asked you in the original investigation. Plan an experiment to find out which one is the best catalyst, how you will use your result to draw a conclusion. So to draw a conclusion, you need to look back at your objective. What is the objective of your experiment? You want to be able to tell after processing a result which one is the best catalyst, the one that will be the fastest rate, the one that give you oxygen gas the fastest. That means if I have a fixed time, after, let's say after 1 minute, what is the volume of gas produced by catalyst 1? And then after 1 minute, what's the volume of gas produced by catalyst 2? And the same thing for catalyst 3. I plot a graph, time taken for a fixed volume of gas to be produced. So conclusion there, best catalyst, the best catalyst would be the fastest reaction, would give the fastest reaction. If you have the fastest reaction, it would take the shortest time. That means the least amount of time, or it would take the shortest time to form or to produce a fixed volume of gas that you are collecting in the gas syringe there. So I mean, overall, this is an investigation type of experiment. This will be in the new type of alternative to practical for the combined science curriculum. That's pretty new for the 5129, but in the IGCSE syllabus or any other 14 to 16 years old curriculum, planning has always been inside those particular curriculum, but it's been very newly implemented in this 5129 combined science. So hopefully you get the idea, what are you changing in the experiment, what do you need to keep constant, your control variable, and what you are measuring, which are going to be your y-axis, your dependent variable, and your x-axis are going to be the type of the catalyst. You're investigating which catalyst will give you the fastest rate of reaction. So the best catalyst would be the one that takes the shortest time. The shortest the time taken for a fixed volume to be produced, that means the reaction is the fastest. That means the catalyst works really, really well. Okay, so that's all really for this lecture tutorial. It's the end of this topic, so stay tuned and yeah, catch more work tutorials associated with this topic in upcoming tutorials that I will get to produce for you. Okay, thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel, and follow me at ptet.chemistry. That's at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected. Thank you for watching again.